Okay. Hey, it says we're live. Anyway, if someone or someone will go ahead and do me a favor on Schoology, check the link and click on it to see if you can see this. It might get a little feedbacky, but if not, it'll give me a thumbs up to know that we're good for like the tens of people. I mean, tens of millions of people watching it. How you doing? Anyway, physics review session for today, which is covering chapter 1. Good. Chapter 1, which is generally about physics. So we got a thumbs up in the back. It's working okay? Thanks, guys. Awesome. So it works?
Yes, sir.
Yeah. You can get yourself on camera if you want. So things to keep in mind as we're doing this are kind of already on the board. We're going to try and do much up here. Hopefully this will stay clear and I can zoom in and all that. Want to know what resources we got, what's being covered, you're making questions, what's on OneDrive, what's on YouTube, what's where. Good to see everybody. Man, this is good. First
Full house.
Full house. I mean, I wish I could turn this camera on. There's like a few hundred people here. What is up, y'all?
327?
327 people. 328. Physics help. All right. So what's covered? Chapter 1 is in there. So we got chapter 1 from the book. Now, the only thing we really need to do on that is remember what we did for news and joke. You also had a little bit of coverage on this when you did phschool.com. Remember the code for that was CSA0100. I'm going to back off one of these guys here. That should be good. So again, that's our start for chapter 1. You can take it multiple times. If we didn't talk about it directly in class, not going to be on the test. So things that you might want to note specifically might be science, technology, and society for sure. So sci, tech, society. That'd be one thing on there. Another thing would be scientific method. Now for scientific method, probably the main or the bulk of that would have been either in regular class or with the Simpsons, which I will do a few problems in that. You're going to want to take note of distinctions with a controlled experiment. So what's your control? What are your variables? So within your variables, we're looking at kind of the cause and effect. So the cause being the independent and the effect, a little bit messy here, being the dependent. Now, if we go a little bit further on that, you might recall that the independent, that's what you're manipulating. So the experimenter manipulates. Close enough. And this is what you're measuring or what responds because of that. So the responding. And again, cause to effect. Remind me, come back to that with an actual example. Okay, so that's kind of chapter 1. You might recall that with a little bit of homework on that. Hey, what's up, y'all? Secondly, and really the bulk of it is going to come in here with conversions. So keep in mind what we had on our quiz, right? We're going to zip through a few of these practice problems. Again, I repeat, so this is what I already have for you. Even better if you can say, hey, can we do this problem? Either a redo from class or you make up a new one that's kind of similar to it. All right, so conversions. And then third, we got how to measure stuff. So measuring stuff, we had our different kinds of rulers with our labs. So we had things where we measured volume, we had things where we measured just a ruler, We had thermometer. We had measurement Olympics just outside. You're not going to need to know percent error, so don't worry about that. So yeah, within this, lots of things with measurement. We did different color rulers. So real quick, in terms of resources, we skip over here and look into our OneDrive, chapter 1. So all these are videos. It's like 20. It's probably more than you can watch, but you can go back through some of them, including, measuring with colored rulers. So if you click on that, you can see, so connect in, and it runs through these guys. So there's a little bit of lag, but that gives you an idea of what was going on. You can remember from class. Yeah.
So do we get to use our conversion sheets tomorrow?
You do get to use your conversion sheet. So you should have with you. So if we go back here, oops, wrong way. If we kick over and look at this, your conversion handout like this needs to be with you. Hey, what's up?
Molly,
Molly, you're a little late.
big Molly.
Hey. So check it out. Not only have this with you, but two parts of it. Most important, know how to use it. Really the only part of knowing how to use, like the top parts here, is pretty straightforward, right? One thing equals another. The trickier part that we should start to get memorized, don't need to have it memorized for tomorrow, but is how to use this part down here. So how to use prefixes. Now, just be honest, the only ones we're going to use are the ones that we've been using, which are, go ahead, shout it out.
Meters.
So have we used mega yet? We have not. Have we used kilo?
Yes.
Have we used hecto or deca? No. Have we used deci? No. Centi, milli, micro. So those are really the only ones you're going to have to know, along with the base unit. Remember, base unit, so when you see the base unit over here, that's referring to this kind of central piece. And that's the measurement without a prefix. So you zoom in, it's liters, meters, seconds, grams, without the centi or the milli or the kilo, right? Cool. So if we jump back, where was I just writing? I was writing right here. One other thing with measurement. So if we go back to the first thing we did this year, we did, how tall was that tree? So you might want to review your notes on that. So anything that's in your notes is fair game, and it should help you, right? You should be able to go back and say, oh yeah, I remember how to do that. So that's it. That gives us, in hot pink, chapter 1 about physics, covers a few things, including, probably most importantly, scientific method, how to convert things, and how to measure things. That'll cover all of it. So things that we did, just a quick note, on like equilibrium. So we did meter sticks hanging between two balance spring scales, not on there. All right, we got that. We got our resources. One thing in terms of conversions that you might want to check, go back to, you can peek at YouTube, look at some of the problems that are in here, just to give yourself a refresher. All right, let's do some problems. Or let's ask more questions. What do we got?
I want to do one of the double problems.
A double, okay. So what do we mean by a double problem? Those are the tricky ones, right? What's that? You want to be in the last one?
No. How many inches do you have?
12.
Thanks.
Thanks. So a double problem. Let's check it out. Double meaning, we'll just go to this one, 16 to start. So everybody write this down. We'll go ahead and do it together. Here's what I think is really important at the start, is to rewrite the units. I'm gonna go 8.41 grams per milliliter, top to bottom, and then Not sure why that K is capital, but whatever. kgs over Ls. That is going to give us grams to kilogram as our first conversion, and as our second conversion, milliliters to liters. So I'm going to do this on the bottom sheet. So 8.41, you can remind me what that said. We'll do it right here. So 8.41 grams per milliliter, and then into kilograms per liter. And we went ahead and said, here's the first conversion in orange. Here's the second conversion in green. So we'll go ahead and set up. We use purple for now. So 2 conversions in here. You can keep the top and the bottom. That's why we rewrote it. So it's not just a slash, but in fact, top and bottom. So it's 8.41. And then we're looking to convert it into kilograms over liters. So I'm going to go into orange. That's part 1. And you see it up here, grams to kilograms. So if we're going into kilograms, here's where we're going, then I need kilograms on top and I need grams on the bottom, and show that they cancel, just like so. And then if we don't recall, we can pull up this guy and see that in fact, grams are in here, here's kilograms, and our relationship is shown here. That 1 kilo unit, so 1 kilogram is 1,000 grams. So 1 kilogram is 1,000 grams. Cool. That's the first part. Again, don't try and jump into the answer at first. Just fill it out step by step. Part 2, doing in green. And we're going from milliliters to liters. So I'm going to need, in this case, notice milliliters and liters on the bottom. So I need liters on the bottom. So it ends up there, right? And I need milliliters to cancel. So milliliters will cancel. And then we put the relationship, which if we look back, for milli, just right here, we have 1,000 milliunits. So 1,000 milliliters equals 1 liter. Okay, so that gets plugged in like so. 1 liter, 1,000 milliliters. So notice what units we're left with. If I highlight it in, I don't know, purple. We have kilograms up top and liters on the bottom, which is what we want, kilograms and liters. Now, you can plug this in as it looks. So if we highlight here and go blue, 8.41 times 1,000 divided by 1,000. If we clear this out.
Yeah, boy. Yeah, so basically,
Which is 8.41. Now,
Wow.
you would not even need to do that because you know that just like grams cancel and just like milliliters cancel, the thousands actually cancel. So I'm going to just cancel those thousands, and you know that your answer is 8.41 kilograms per liter. Hey, real quick, if you didn't sign the sign-in sheet, would you go ahead and do that? You can keep passing around. It's just for me to know. I'll put a column in the grade book that is not weighted, so it doesn't actually count towards your grade, but it's just to keep track of who was here.
Be good, boys.
Nice. Thank you for coming. How about another question?
The one above that, above 16,
What was that one? Let's look.
15.
Haha. All right, so this one's a tricky one, but why not do it? So what's tricky about this? Yeah, we got this guy right here. We got an
Yeah.
exponent.
Is that gonna be on the?
This is not gonna be on the test, but huh?
Shouldn't we focus on stuff that's on the test then?
Yeah, that's a good question. Now, we'll leave this till later.
Okay.
But why you would not just focus on what's on the test? Because sometimes if you learn something that's a little more challenging, it can help you understand the things that are easier then. Right? That's why you maybe train harder than the game and still have it be useful. Either way, we'll hang on to that one for a little bit. Let's do 12. So again, better for you to do it ahead of me, even if you get it wrong. So no matter who you are, even if you're at home, let's get this one rolling. I'm gonna go ahead and rewrite it for you right below that. 0.74 kilocalories. What is falling here? Oh, markers. Kilocalories per minute. Converted into calories per second. Quick note up here with abbreviations, things like M, MI, MIN. These are all different, so make sure that you're using the right one. M for meters, MI for miles, MIN for minutes. And if you're ever confused, what do?
Ask for help.
Use that, just raise your hand. Say, wait a second, are we talking about this? Or are we talking about this? Also, as you're doing it, make sure you know like the path. Hey, should my number be getting bigger? Should it be getting smaller? Does this make sense? All that. All right, I'm going to transfer this one down. 0.74 kilocalories a minute. You know, I'm going to add a page in here. This was 0.74 kilocalories per minute, yeah?
Yes.
And then we want that in just regular calories per second. Now, do you have to write on here the steps? No, you do not. Is it helpful if you do it? Yes, it most definitely is. Again, if you are like rock solid 100%, sure. But this is how I do it. You're kind of stuck in class anyway. It's not like you're getting out to go to a party or go swimming or to get some hamburgers or spaghetti or something. If you're stuck here anyway, you might as well. Spaghetti? So,
Carbs all day.
How was lunch, by the way?
Carb load every day.
Oh, it was delicious.
Did we have a good lunch? Oh, somebody took your seat.
Meatloaf was
delicious.
Yeah. All right. Anyway, we're going to set up like so. Big old line. That was a good entrance and exit. I 0.74 kilocalories in a minute. And we're going to calories in a second. Step one. Now, you don't have to color code it. One of the reasons why I'm doing it on here is it's easy to switch colors and it's fairly neat and I can screenshot it and save it for you, all that kind of jazz. But certainly not necessary. But for you, again, keeping proper spacing, definitely going to be helpful, especially if you're a messy handwriter. I don't have the neatest handwriting, but problem solving should still be easy to follow. So one, we're going from kilocalories to calories. So kilocalories over here, calories in the end. So that means I need calories on top, kilocalories on the bottom. So it's just like meters and kilometers. liters and milliliters, or kiloliters, sorry. So that means 1 kilocalorie is 1,000 of these guys. Now, if you look on like a food label, when you see calories, it always has capital C. And that's actually the same as a kilolittle C calorie, just in case you're wondering. Now you know. And then the second phase, if we do that in, I already had it in blue, but we'll switch up the color. So it's distinct purple. We're looking at this, minutes to seconds. So we have minutes on the bottom. We need seconds on the bottom. So I'm gonna put seconds on the bottom. I need minutes to cancel, so I put it opposite side. Minutes cancel. Oh, I should have shown that kilocalories cancel.
Sure.
Minutes and seconds are related in this way. 1 minute is 60 seconds. Now here's a question from the test. What must a conversion always be equal to?
0. 1.
Itself.
Must always equal 1. Which is what we talked about before, because they are equal to each other, right? We could rewrite this as 1 minute is equal to 60 seconds. And therefore we have this conversion method. Or earlier, right? For any of these things, this has to equal 1, which is why it's legal to say, hey, this thing over here equals this thing over here, right? The only way to take, A and get A over here, say we'll call it B or whatever, is to multiply it by 1, right? You can't multiply A by 10 or 15 or 8.41, only can be multiplied by 1. So all these, in order to be legal, need to be equal to 1. Hopefully we wrote that down. Why would we want to write that down? Because I said it's going to be a question. Not maybe, it is, right? Like none of these other questions are directly on there. How to do it is on there. That's on there. You watching now? Okay. Anyway, math-wise, what are we doing? 0.74 times 1,000 divided by 60. Let's see what we get. 0.74 times 1,000 divided by 60. Hey, that works. We get 12.3 kilocalories in a second. Now, if you don't have your calculator out, take it out. Because even though I'm showing you on here, although it gets a little bit cut off, you want to practice this. Because sometimes your order of operations gets messed up or you're not totally familiar with your calculator. Get familiar with it now so that you don't make an arithmetic mistake. That would be a bad way to go. All right. Let's shift gears for a second at least. Talk about scientific method. What do we use for scientific method in here, primarily? We're talking about Simpsons. And one of the things was looking at Lisa and design experiment. You may want to keep that in mind. One thing we mentioned was establishing a baseline, making sure you had a control. So when Krusty was running, we realized, hey, there's no control on that because each group was being manipulated. So we need a control without treatment. So you got like classic experiments, even kind of like we're doing in the back, right? So if we had some plants that were growing and we wanted to test the effects of a new fertilizer, or how about we got some new grow beds in the back, so some special lights, we're going to put some plants underneath to see if they work well. So maybe we want to say, all right, what happens when you have a plant, just say in the window versus under those lights? Maybe plant outside, maybe a plant with different filtered lights. You need to make sure you had a baseline. Like, how is this plant growing in the classroom independent of, say, window light or the grow bed? Your variable, Again, you just want one. So if you wanted your variable to be light, so if we go back in here and we had, you know, our eco columns over there look kind of, we'll simplify it. You know, just to be like this. Good enough. So if this is our plant and we want to test what's happening with light, right? What are some of the things that we do not want to change? So keep in mind, variable, your experimental one is what you're manipulating. So we want to change the light. Now, you'd want to say, all right, the light intensity, the light duration, light source, the light wavelength, those would all be possibilities. You'd want it just to be one. And then as you move this plant around the room, we'd want to make sure that we controlled for things like, what wouldn't you want to change?
Plant.
The plant itself. So you wouldn't want different species of plant. So we'll put in here, this means no change or keep it the same. So that'd be the plant species, probably the plant age, right? You wouldn't want one that was really big, one that was really small.
That's like control.
Oops. It does say control, a little bit messy on there. You'd want to keep in mind some easy things like the temp, the humidity, right, the distance from the light source, all those things. The soil, you know, how well watered it was, the water level. And then you could change the light, right? Maybe even you wanted to do an alternative one here where you did different colors of light. Then you record the different growth. So all different possibilities for what you change. Only thing you got to make sure of is it's only one thing, one at a time. We also mentioned the importance of doing it for a proper amount of time. We mentioned the importance of having good numbers, so high numbers, multiple trials. Okay, so in this example, which is okay, but the thing is, it's general enough to apply to anything that we're looking at. So if we go back to Simpsons, right, we've got it with Smithers and special juice, Homer with the green slime, Bart with the radio waves and the mice, Krusty, again, an imperfect one with itching powder. So again, we're looking at these kind of things. And then Lisa with the hair growth. So all those things would be other examples we could use. In this case, for the variables, we want to know what is the independent and what is the dependent. Independent. Yeah. Sometimes I can't spell. Nice. Just a reminder, independent is kind of the cause. Dependent is more of the effect. You are adjusting. You are controlling. You are manipulating the independent variable. So in that case, or in this case, what is that? The color of light. And then the dependent variable, what would we be testing because of that? Plant growth. So you'd say like, I mean, you could even do that in more than one way. You'd want to pick one way. I mean, you could say the number of leaves. You know, you could measure the amount of CO2 it's using, the amount of flowers it produces. Maybe we'll just say, you know, something a little easier to measure, like plant height, right, which is meant to be a measure of the growth. All right, so we'd want to definitely be able to put together some kind of experiment where you answered these kind of things, like where the variables was control, independent, and dependent variable. Something else that might be on it would be observations. And then keep in mind, we're going to build on this as we go. Right, this is early on, so we haven't had, you had previous year's experience, but this year you haven't had a ton of examples of this. Cool. When you are measuring, so measuring really only involves one thing. What's our rule for that? One rule to rule them all? What's up? Oh, that's cool. There's no time frame on this. What's the one rule for measuring? Always measure to always measure to one uncertain digit. Now, a reminder of what we mean by this. We go back and we see at the very bottom, measuring with colored rules. Hey, what's up? Hey, if you're coming in a little bit late, no problem. Get the sign-in sheet. So I'm going to pull this out, see if we can get a replay on this. And this is good enough. Right? It shows you the green, blue, and yellow rulers, each with different markings. So you need to look at your instrument and see what's on there. Down in front. Yeah.
Can you talk about how, like, whenever we do the conversions, like, whenever we write our answer, like, the whole uncertain digit thing, and, like...
Okay, so how we write our answer? Like, in terms of whether I write 12.33333?
Would you kind of find it, like, 12.3 repeating, like, your exercise?
Yeah, so the question is, how are we writing our answer? Now, it's important to note that there is an exact way to do this. We're not there yet. So the exact way to do it would be to follow what's called significant figures. And real quick, that's just to say, basically your answer can't be more exact. Hello? That is. The answer can't be more exact or precise than what you started with. So basically, this first guy's got 3 digits here, 1, 2, 3. So you'd go with 3 at the end. Now, if you put 12.33, that's fine. For our purposes, for now, 1 or 2 decimal places is cool. So don't go ahead and give me like a, 12.4813021987 like that. 1 or 2 is cool enough. But it's also important to note there is a way to do it. We just haven't gotten there yet.
What about the whole, like, uncertain digit thing?
So an uncertain digit isn't going to factor in on this. An uncertain digit is going to factor in on when you have an actual thing to measure. So this is with like a ruler actually in lab. So if you have a meter stick like this, and this guy, you can see, actually, let's just do this. How about, we'll try this out. See if this works. Okay, check out that. Cool bird. Sweet. All right, so this guy's up here. If I have Post-it and want to know, what its measurement was, if we put it underneath over here. All right, a little bit hard to see, but I think you guys can do it. So if I want to know what the measurement of that is, we're going to roll through our same set of ideas, same set of thinking. What do we know for sure? And then end with one digit that we're estimating. So if we go back even to here, so one uncertain digit, what we also mean by uncertain is that you're going to estimate the last digit. And here's what we mean by that. Okay, so we look close. This Post-it is definitely 64, like 100%. It is definitely not 65. Everyone would agree with that. Then we can get finer, more granular. So it is 64.1, 2, 3, 4, 5, 6, and definitely not 64.7. So this instrument goes to the tenths place on centimeters, right? You can see 64.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 66, it goes on and on. Okay, therefore we got to go one past that. So instead of it just being 64, or instead of just being 64.6, this guy looks to be pretty dead middle on that. So 64.65, where that 5, oops, I just moved it, where that 5 is the uncertain digit. So 64.6, and then I'm just writing a different color because I got the option here. This 5 is what you were estimating because there is no space in between there. So it's close enough to where it was. But you see how right in here, it's about halfway through, but there's no more lines in there. You could imagine if you had like a really fine marking tool and you like zoomed in, with a hand lens or microscope, you can imagine putting 10 more lines in there, in which case you'd have to go one more digit. Yeah.
Are we going to have our own rulers?
You won't, but I will have pictures of instruments. So, basically like a picture of this, and I'd say, how big is this? So if you wrote on here, oh, by the way, big mistake here. Make sure we had centimeters. But if you wrote 64 centimeters, and 64.6, but the same is true if you wrote 64.650 or something, that would also be wrong. So you're going to need to know based on that instrument. And so remember when we went on the stations? So stations are actually in here, right? So if we click over to Measurement Mania, I don't know if I erased the answers on here. We got it for protractor, right? And this instrument goes to what place?
50 degrees.
Goes to the tenths, right? So you can see a whole number like 50, so tens and ones, but then you got a breakdown in here, 1 to the rush 10. So you would need to go one further. So if it were like 50.2, you have to go 50.21 or something. And then if we get further, right, we had in here where you looked at the Erlenmeyer flask versus a regular beaker, right? We brought in some stuff from home. Obviously, if it's a digital scale, it's going to kind of tell you automatically. We use these guys for Measurement Olympics also. So again, Measurement Mania and Measurement Olympics. Probably easy to confuse what the difference is. Thermometer in there, right? It shows you only to the whole number. So 21, 22, 23. It doesn't show you past that. And therefore, to the tenth place, 1 decimal point is where you'd need to go. So remember all this? Dealing with liquid measurements, cool. Got these guys, right? So this is kind of the same thing that we just dealt with, except we did it live time. Anyway, this is just a reminder, even with this on a scale. Cool. Let's do another multiple stepper, but that's covering pretty much everything. By the way, would you guys want me to share like these notes that I'm drawing up here? Thumbs up, down?
Yes.
Cool, then I'll do that. So if we go back through these guys. Oh, the other thing, forgot to mention the price of admission, how much it costs to get in today. All right, true. It is $0, but it's not free. So anytime you come to a review session, even now that we got them on, YouTube and live stream, you got to share this information with somebody. Preferably somebody from class who couldn't make it. Or even if they just didn't want to go. Even if they're just sitting at home or in the library playing video games. You got to share this with them. Why? Because it's helpful to them. And for you to reteach it is extra helpful. So you can be the helper and it solidifies the knowledge. So we're going to do, what is it, one more? And then we're good? All right. How about just, this is one that you would very readily see tomorrow. 3 days, how many seconds is that? We're going to skip down here. Keep in mind, you can stay after if you want to ask some extra questions. No problem. Okay, so we got, what color? Hot pink, right? 3 days equals how many seconds? All right, now you probably don't know how many seconds are in a day. I mean, maybe you do, but we'll just pretend you don't.
3,600.
All right, so I'm going to go from days into hours, hours into minutes, and then minutes to seconds. That gives me 1, 2, see you later. Take care, everybody. Peace. Hey, stop in tomorrow if you still have questions. So 3 conversions. I'm going to set up like so. 1, 2, 3. And where do we start? 3 days. And we want to know how many seconds that is. You just put an S or SEC, whatever. Doesn't matter. So I'm going to roll up here. Purple, 1, 2, 3. And then start with orange. So we're going to go first up, days into hours. So whatever we're going into goes up top, in this case, and then days on the bottom. And we know that what happened? Sorry. I'm on the eraser, that's why. 1 day is 24 hours. Cool. Days will cancel. Then we're going to go to step 2. Step 2 is going to be from hours to minutes. So we need minutes up top, hours on the bottom. Hours will cancel. And we know that they are related in order to make it equal to 1. 1 hour is 60 minutes. That leaves us with step 3. Step 3 has us going from minutes to seconds. So we need seconds. Seconds up top, minutes on the bottom, and they cancel. 1 minute is 60 seconds. So look at it, everything's canceled right now, except for seconds, which is what we want. The math involved in this looks like so. Clear this out. So 3 days times 24 times 60 times 60 equals
259,000.
We agree with that? 259,200 seconds. And that's it, y'all. Anything else? Anybody else? All right. Thanks, guys. Appreciate you coming. I don't know, you can email me with questions or maybe post comments in the bottom or whatever. Take it easy, everybody.
How many people are viewing the live stream?
Oh, it's a million?